welcome back. Now, in previous lectures, I've talked a little bit about how the environment influences human health, perhaps by natural disasters causing injuries, or by chemicals or exposures causing health impacts, cancers, for example. Another way to think about this is, how does humanity and our growing population influence the environment that we live in? And this is another really important framework for thinking about this, because I think we'll see increasingly that those those impacts actually have major impacts on our health overall. So let's talk a little bit about this. Now, one of the ways that we address the impact of humans on health is by doing an ecological risk assessment. So this is where we look at different types of activities that we take on, new procedures, new technologies, new construction efforts, etc., new chemicals that we use, and look to try and see what the impact of those new changes will be on the environment. So we know that we actually have fairly massive ecosystem disruption. Ecosystem disruption is a real concern, right? When you have an ecosystem disruption, well, not only is it bad for animals and plants, but it's also bad for us, right? Because if you don't have bees, you don't have pollination. If you don't have pollination, you don't have food, right? So the ways in which this affects our health are fairly extensive. If you cut down all the trees, you get mudslides. If you suddenly have a lot more wildfires, then you have particulate matter and you have more asthma, right? So there's a wide range of ways in which our influences on the ecosystem ultimately will impact us. Now, when we think about ecosystem impacts, we're having a dramatic effect, generally speaking, in terms of wildlife. So it's estimated that our rate of extinction is about 1,000 to 10,000 times what the natural level would be, based upon our knowledge of the fossil record. So we're seeing a huge die out of a huge range of different species, largely due to effects of human action. We also see impacts like effects on different types of sentinel species. So sentinel species are species that can tell us whether or not different types of chemicals or other types of health impacts maybe actually are having impacts on humans as well. So example here would be frogs. So we've seen an upsurge in terms of strange mutations for frogs, probably due to a range of different chemicals that we're putting onto the environment. Many of these we don't entirely know what the cause is, and that's an indicator to us that these species that are very vulnerable to these chemical changes, well, maybe these are effects that we'll also see for humans as well. We also know that increasingly wildlife is being pushed into the margins. There's just less and less of that wildlife. So they estimate that roughly by mass of vertebrate species on the land, humans make up about a third of that mass. Domesticated animals that feed us make up another 2/3 about, and wildlife only makes up about 5% of that mass. So increasingly, we're centering the entire ecosystem around us, and that has distinct risks when you create a very fragile environment around us, and we don't entirely know what those risks are sometimes. So we have a tremendous population growth in terms of humanity. We're looking at projections up in to 9.2 billion by 2050, right? So and we're above 7 billion right now. So we have a lot of people, and this is a real change from history. You see that there's this tremendous upsurge, and when you have this upsurge, well, we have more needs and wants, right? So it's not just that we have more need for food, we do, but there's also a way in our society that, American society, where we have this consumer element of things. We're not just getting what we need, we're also focusing on the things that we want. So we actually consume a huge amount of objects and resources to make ourselves happy, in part because we have a lot of resources. So that's a real consideration. When we look at this consumption overall, we produce a tremendous amount of waste. So per capita, we produce about 4-5 pounds of waste per day, per person. So that sounds like actually a fair amount of waste. But when you actually look at the amount of waste that we produce through other sources, for example, sewage and industrial waste, well, when you look at industrial waste, for example, per capita, well, that's almost 300 pounds per capita per day, right? So a lot of the waste that we produce, we never see. It's not the things that we throw out. It's the waste that's produced upstream by industry to produce the things that we then use, right? So, there's a tremendous amount of waste that's being put out into the environment, most of which we never actually see. And many of it, for example, animal waste to produce food that we eat. So there's a lot of different things that were environmental impacts that extend beyond what we consume, what we directly consume. All right, so I'm going to talk a little bit about climate change, and I talk about climate change because I actually think that I'd be doing a disservice if I didn't address this in a fair amount of detail. It's my belief and the belief of many that climate change is going to be the primary environmental risk factor and possibly the major health-related risk factor that we're going to have to wrestle with in the coming century. So, this is a major challenge. We've seen it, this progression at a political level in terms of trying to think about how we're going to address climate change and its progression. It's moving much slower than many people would like. This is an art piece by an artist where it's called Politicians Discussing Climate Change. You get the message there. There is an increasing sense of urgency here. So let's talk about what this situation actually looks like. Well, what we're seeing is that we have this large increase in release of carbon dioxide into our atmosphere. So if you look historically over thousands of years, over time, you do see this fluctuation in terms of the amount of CO2 in the atmosphere. However, it's never really gone above 300 parts per million. However, at this point, as you can see from the graph at the bottom, the amounts of carbon dioxide in the atmosphere have just skyrocketed. We're now over 400 parts per million. We're about 410 parts per million. So what we see is that there is this relationship between carbon dioxide in the atmosphere and overall temperatures. So if you look at the CO2 concentration, you see that it correlates with an overall increase in temperature. And that increase in temperature is what we're calling global warming or climate change. Okay. Now, this isn't just a correlation. So we're not just saying because CO2 goes up, the temperature goes up, and that, it's just a correlation. We actually know more than that. We actually know a lot about the chemistry of CO2 and how it affects the way that the environment accumulates warmth. We also know a lot about, we have data that shows what is actually causing this reflection of heat back into the atmosphere. And we know that it correlates with the signature of CO2. So we know that more than just a correlation. We actually know at a fairly deep scientific level that this increase in CO2 is actually increasing global temperatures. And and we also know that the increase in CO2 is also correlated with human activity. So this is a problem that we are causing. So when we look at overall global carbon footprint in terms of emissions of CO2, well, there are two big hitters when it comes to this, and that's the United States and China. The United States, that's the large red globe there. That's the production of CO2 that we're producing. And then the large blue one is for China. Now, China has a very large impact in terms of emissions. But remember that a lot of the reason that China has such a big impact is that they're producing, they're an industrial nation, and they're producing a lot of the things, the export that they send to the United States and to Europe, right? So we're the two major partners for products that China produces. So even though it looks like China is producing a lot of these emissions, a lot of those emissions are actually really to produce things for us. So in some ways, we're actually we're the cause of those emissions. If you look per capita, the United States is one of the biggest per capita consumers, producers of emissions in the world. So we produce a tremendous amount of emissions here in the United States. Now, when we think about climate change and addressing this climate change, well, there's a few different scenarios. This is presented in Celsius. Multiply this by slightly less than 2, and that will give you the numbers in Fahrenheit. But if we did nothing, we would expect that the increase in temperature would be somewhere around between 4 and 5 degrees Celsius. And that is a huge, 9, 10 degrees Fahrenheit change in terms of overall global temperatures, which are, if you look at the impacts on the environment, most scientists estimate that would be catastrophic for our ecosystems. With current policies, we expect that there'd be an increase somewhere in the 3 range, and with pledges through the Paris Climate Accord, we expect that will be somewhere in the 2 to 3 range, based on those current pledges. The hope is that from the Paris Climate Accord is that through increasing pledges and improvements, we'll get it down into the 1.5 to 2 range. But one of the concerns here is that we've already pushed the CO2 levels really high, and it's going to take a long time to actually bring those down to levels that would decrease this trajectory of global climate change. It's not a question of whether global climate change will happen. It's already happened. It's already happened. The CO2 is already out there in the atmosphere. Really, even if we cut down our emissions to 0 today, we would still have problems with climate change because there's so much out there in the atmosphere already. So it's not a question of if, it's already happened. It's the question is, how can we minimize that overall impact? So what does this actually look like when it comes to health? So we know that extremes of weather have a major impact for population health, right? So if you look at the distribution of weather in 1951 to 1980, there's something that you'll notice. The red and the blue represent lower than average, and red represents higher than average temperatures. So you notice as we get up to the 1981 to 1991, that curve is shifting as we're getting increasing emissions. And then as we get to 1991 to 2001, we see an increase in number of the extremes in that bell curve. So there's 2 things that you see. One is that you see an overall shift to higher temperatures. So the dark red there is what we call extreme temperature events due to extremely high temperatures, right? So we'll see less of those extremes in terms of low temperatures. We'll see more of those extremes of high temperatures. And we also see a broadening of that bell curve. So we'll get more extremes in both directions. So what does this look like in terms of health? Well, there's a range of different things that we expect that climate change will produce. And one is change in air quality. So change in air quality is partially due to the fact that we'll have more wildfires. We also find that when you have increase in temperature of the atmosphere, you often have greater collection of particulate matter in environment, for example, around cities. So it can sometimes trap particulate matter and result in poor air quality. We also, so there we see the increase in pollution. We also see that with changes in temperature, you can actually have an increase in allergens in the air that are maintained in the air and produced overall. So, for example, increases in the length of the ragweed season, so that we'll have more pollen, which a lot of people have allergies to and responses to. So what we can expect from this increase in particulate matter overall and lower air quality is impacts on cardiovascular disease, impacts on lung conditions, asthma, for example, and other types of health impacts. And another impact that you'd expect to see, recent research suggests that there actually will be a huge impact on diabetes from these impacts. So there's a range of different health impacts that we're expected to see from air quality changes. We also expect to see more extreme weather. So this one component to this would be increases in flooding and storms. So many people ask the question of, was this storm caused by climate change or not, and trying to parse it out in that way. Well, the thing is that climate change, as average temperatures increase, we expect that the air can actually absorb more water, right? So for every temperature, you expect that every degree, the air can absorb about 7% more humidity, okay? So on average, what we see is that currently we have about 4% greater water in the air. Now, what happens when you have more water in the air? Well, you have more powerful storms, right? So what we're seeing is a potential upsurge in these extreme weather events in terms of hurricanes and floods, which is of substantial concern. You also expect to see more droughts as well. So certain areas, when it comes to these extreme high temperatures, we'll see these droughts, which can have major impacts on health. If you look at historically, droughts actually were a major cause in terms of all the disasters that are happening in Syria right now. So there was a major drought, which led to food insecurity, which led to violence, right? So these can be disruptive in major events. We can look at impacts on water and contamination. We can look at property loss. We can look at damage that comes from these extreme weather events. And you can anticipate that this can cause major injury and health impacts from these extreme weather events. So you can also expect that they actually increase the likelihood that you'll have waterborne disease outbreaks as well. All right, so this rising temperature actually also has major health effects. So this temperature itself can actually affect people. So people can get heat stroke and various different diseases. Again, this can affect cardiovascular disease and other health conditions, diabetes, for example, and lung conditions as well. Dehydration is also really dangerous. So we need to think about how this will affect people who are in these extreme environmental conditions. So we know, for example, that farm workers very often have to work outside. Farm workers are often immigrant labor, who are vulnerable and in situations where they're working in conditions that they really shouldn't be working in. We also know that children and the elderly are particularly vulnerable to these high temperatures. So it's a serious concern. We also have a change in terms of vector-borne illnesses. So diseases, the range of these diseases has actually shifted, so that we're getting diseases that we wouldn't normally expect up here in Washington State. So we're seeing in Washington State an increase in West Nile virus, things like ticks, Lyme disease. So there's this expansion of these fairly dangerous diseases into new territory because of change in climate. Here in Washington State, for example, we're seeing a lot of climate change related effects. So we've seen major extreme weather events. For example, the fires in near the Columbia River. We're seeing that we're getting droughts. We're We've had things like the mudslide in Oso, right? So we're seeing some of these extreme weather events. We're also seeing changes in infectious disease as well. There's also a lot of concern about the impact on our ecosystem. So projections are that we're actually going to lose a lot of our snowpack, and we rely on our snowpack for in the mountains. We rely on that snowpack for water, right? And then there's increasing temperatures are likely to have a major impact on our salmon, for example, and our fishing industry. So when you have that happening, you have changes in the ecosystem, and you also have changes to water systems when you have disruption of water from the snowpack. So there's a lot of different things that we can think about and be concerned about here in Washington State, and also a lot of opportunities for thinking about how to address those possible health effects. The other thing I'd also mention is that we are seeing increasing temperatures, and we're expecting to actually see some more of those heat-related health effects. Now, I've talked about this more locally in terms of the United States, but the truth is that the change in climate is likely to have a global impact. And what we know is that it's really the global north that's producing most of these emissions. They're the ones causing this problem. That would be us. And the first of the chart on top is showing the emissions produced by different regions. You'll see, if you compare the United States, for example, to Africa, you'll see that we're producing this problem. We're producing the greenhouse gases that we're concerned about. However, if you look at major per capita from anticipated mortality from climate change, looking at 4 different types of climate change health effects, what you see is that the major populations that are likely to die from this climate change is actually going to be in the global south, right? So it's the people who aren't producing this problem who are likely to be most impacted by this problem in terms of health effects. So even though we expect mortality to increase in the United States and other regions, this might be a very profound and serious problem in other countries that have less resources to deal with them and actually aren't responsible for having caused the problem to begin with. So in the United States, we're currently the only country that isn't signed, that has stepped out of the Paris Climate Accord. We have broad international agreement that this is a problem. In the United States, it's interesting. Actually, most people recognize that climate change is happening. So here, any yellow to orange to red colors here represent over the majority of people in those regions believe that climate change is actually happening. So as the United States, we agree that this is something that's happening, that we're having increasing temperatures. However, there seems to be a much greater difference in terms of who thinks that humans are actually causing this climate change. So that's a much more strongly debated question, in part because there's been a very systematic effort, political effort, to make the argument that we don't need to make this change. And this comes from a wide range of different sources. A major source of them, this is, funding and support from industries that benefit from these emissions that we're trying to address. So that's a point where, in terms of getting agreement as a country around our path for the future, we really need to work on. The other thing that's kind of interesting about how we think about climate change in the United States is that there's a big difference between how people think about climate change in terms of the impacts for others versus the impacts for themselves. So if you look at people's belief that climate change will have a negative health impact for people, actually majorities of people think that yes, it's going to have a serious impact. However, if you look at people's belief that that impact is going to be for themselves, well, actually the majority of people actually don't think that that climate change is going to impact them personally, right? Now we know that given our evidence around the impact of climate change, we actually don't believe that that's true. I think it's likely that these climate change effects are going to affect everybody. So it seems that people don't have a perceived threat with respect to this environmental threat. The other thing that we know is that there's a wide range of difference in terms of how often people actually talk about this. So for large portions of the country, people just don't talk about climate change. They're just not very likely to actually address this issue. So it's just not a polite thing to talk about in certain communities. So people avoid the topic. Whereas other areas, it's a much more of a hot topic that's discussed more widely. So when we think about this from a public health framework, we really want to consider how to solve this problem. So the one obvious answer is to think about mitigation, and that's a reduction of emissions. Now, the majority of emissions happen through industry sources, but a lot of it happens also through transportation. So we can think about addressing those things on a policy level and on a behavioral level. So can we do things to decrease the emissions that we are producing, decrease our consumption so that we're not producing as many emissions, okay? So there's a lot of thoughts around that. And when we think about climate change and policy around climate change, very often people focus on that mitigation thing. But from a public health perspective, a really key component to what we can do is think about adaptation. As I mentioned, climate change is here. It's already happened. We can't stop it from happening, even if we stop producing emissions right now, right? So we need to figure out how we're going to deal with a wide range of health effects that I talked about earlier. So how are we going to deal with these severe weather events, these hurricanes and droughts and other situations? And how are we going to address, changes in air quality, right? What are the things that we can do to handle extremely high temperatures? So I've talked recently to a student who's working on a project to think about how we can raise awareness about what to do if we have really high temperatures in the Seattle region, right? So telling people to find places that they can cool down, for example, how to protect oneself, and how certain vulnerable populations, perhaps people who have disabilities, can handle that situation. So from a public health perspective, we really think about how can we address these health issues and decrease the health impact that they will have on the public. So I know that this is a challenging situation that is probably stressful for a lot of us. But what I can say is that there is hope. We as a society have come together before. A global society have come together before to address these types of international issues. So when we come to, for example, CFCs and ozone depletion, we found in the mid-'80s that these CFCs were dramatically affecting our ozone layers. It was increasing impacts very rapidly. And people recognized that, and they were very concerned about that because if you have ozone depletion, well, that increases radiation and skin cancer and mutation rates as a result. So it could potentially have a really negative health impact, right? So people came together and created the Montreal Protocol. And what we see is that these CFCs that are up in the atmosphere, they're going to increase for a while because they just maintain in the atmosphere for a really long time. But we do see promising signs in terms of possibly bringing that down, because the Montreal Protocol actually did effectively decrease our emissions of CFCs. So we can do those things. We can make decisions to make change. And the Paris Climate Accord is a really great movement in that direction. And many countries are actually exceeding their goals for decreasing their emissions. So this is an exciting time. There's a lot of work to do, a lot to think about there. So again, this talk was really thinking a little bit about how do we, given that we're an increasing population, we consume a lot of things, and we produce a lot of waste that has a huge impact on the environment. How do we think about that in terms of the impact on the ecosystem, and how do we think about that in terms of decreasing ultimately the impact on our health? Because we are part of the world. We are not separate from the ecosystem, and we do rely on it for our health. So thank you all for listening, and take care.